Today we're looking at solving simultaneous equations, and more specifically, it's using the substitution method. So that's pretty much our learning intention today. We want to be able to solve these a variety of simultaneous equations, and we are using this substitution method. So by the end of this lesson, we should be able to understand what it means to solve simultaneous equations, and then also look at determining simultaneous equations by graphing them, but also finding the solution algebraically and using this method. So when we're looking for a simultaneous solution to simultaneous equations, what you'll usually get is two equations that have two unknowns in it. So what we want to do is we want to find two values that we can substitute in so that both of those equations produce a correct equation. So the first part is we're just going to look at what it means to have a simultaneous solution. So we want to show that 2, 1 lies on the line y equals to 3x minus 5 and the line y equals to 3 minus x. So if we start with y equals 3x minus 5, we're going to substitute in this x value and this y value. So our left-hand side is y, which is equal to 1. Our right-hand side is 3 times 2 minus 5, which is also 1. So our left-hand side and our right-hand side are equal to each other. If we do a similar thing with the second equation, y equals to 3 minus x, the left-hand side again is 1. The right-hand side is 3 minus 2, which is equal to 1. So again, you can see the left and the right-hand side are equal. So left-hand side equals right-hand side. So again, going back to this idea of does a point lie on a line, we can see that both of these equations are true. So yes, 2, 1 lies on both of these lines. And what that means is when we go to draw it, so say for example, we've got one line that goes this way, one line that goes this way. What we're saying is this point right here where the two lines cross over, that's going to be 2, 1, and that is the solution to a pair of simultaneous equations. Now, one way we can work out a simultaneous solution is, as I've just done here, we could draw a picture and then find where that point of intersection is. Now, in order to use this method, you do need to make sure that you draw your diagrams to scale, and you need to make sure you measure it out quite carefully. So it helps that on my page I do have my grid dots. So here's our example. So graph these two equations. So I've got two formulas here. They're linear because they're straight lines. So I'm going to graph them and then work out the simultaneous solution. So the pair of values, the x and the y coordinates for which both of those equations will work. So let's start with y equals to 2x minus 1. We can use the gradient intercept form to work out the equation of the line here. So we know the gradient is 2, well that's 2 over 1, because we need rise over run, and our c value, or our y-intercept, is negative 1. So we're going to start at negative 1, we're going to go 2 units up, 1, 2, and 1 unit across, and then we're going to mark a point here. So the line that we're looking at goes like this. So that's y equals to 2x minus 1. The other equation we've got is 2x plus 3y equals 9. And for this particular equation, it might be easier to use the intercept method. So remember, there's lots of ways that we have to graph lines now. When you're looking at an equation, you want to pick the one that's going to be most efficient for you. Or if you're not great with efficiency, just pick the one that you know how to do well. So if I were to try to go to gradient intercept, what I would need to first do is make y the subject. So I'd move everything away in order to work out the gradient on y-intercept. But instead of that, I'm going to use the intercept method, which is to put in x equals to 0 and y equals 0 to solve for two values. So if x is equal to 0, then we've got 0 plus 3y is 9. So then the y value is 3. If I substitute in y equals 0, then I've got 2x plus 0 is 9. So then x is equal to 4.5. So that gives us 2 points that we can then use to draw our line. So we've got the point 0, 3, y-intercept, and we've got the point negative 4.50, and that's just there. And then so what we can do is we can draw our line through those 2 points. So I'm just going to shift my line up a little bit. There we go. And then we're looking for where the 2 lines intersect. So let me just label this line 2x plus 3y equals to 9. So then you can see clearly there's our point of intersection, and the coordinate there is 1.52. So then the simultaneous solution is going to be x equals to 1.5 and y equals to 2. So what we can do is we can check it by substituting those values into each of those equations, like what we just did, and then what you'll find is both of those equations will work. Now, we don't always want to be drawing diagrams to scale. So that's why we come up with algebraic methods. So when we're just purely looking at algebra, we're not looking at having to draw things to scale. So the substitution method, we've actually done a bit of already this year when we were looking at quadratics, so parabolas and lines, when we were trying to find where the points of intersection of those were. But right now we're just going to go back to basics. We're just looking at straight lines. So the substitution method is probably the most common one that we do use because we can use this with linear and nonlinear equations. Next lesson, when we look at the elimination method, that will only work for linear simultaneous equations. So that's why this was probably the more powerful one. So how we go about answering these questions, here's your steps, and they're actually the same as the ones that you did last year in Year 9. So the first one, name the equation. So I'll usually use equation 1, equation 2. You might see textbooks use A and B, or I and II. Okay, so whichever way you want to work it out. But the important thing for substituting is that we need one variable to be the subject of one of the equations. Okay, so we're going to pick one of the pronumerals to eliminate, and it has to be the one that's the subject. Step 2 is to substitute that expression into the second equation. Then we solve whatever's left over for the letter that's there. Once we've done that, we need to then substitute the value we got in part 3 into one of those initial equations to get the value of the other letter. So say, for example, if you've got x's and y's, you might do a substitution and you get rid of all your y's. You'll then need to find the value of x, and once you've got x, you'll need to substitute back into a formula so you can work out y. So you always need both values in order to have a simultaneous solution. And then your final step is to write your final solution. Sometimes we may write it as a coordinate. So if we're using x and y, often a coordinate is a good way to write your equation. Your solution. But you can also just write them as 2 separate values. All right, let's have a look at this example. So solve the pairs of simultaneous equations. First thing I'm going to do is label my equation. So that's going to be equation 1, and that's going to be equation 2. If you look at this first equation, can you see that you've got y as the subject here? So what we're going to do is we're going to substitute, we're going to replace y in the second equation with 2x plus 3. So my step sub 1 into 2. So I always write out what I'm doing so that I can inform the marker, this is what I'm doing and this is why I get the next result. Okay, so what we're doing is we're starting with the equation 3x minus y equals 6, and what we're doing is we're getting rid of the y and we're replacing it with 2x plus 3. Now make sure you remember to put brackets around it because you've got the minus, so that's actually minus 1 that you do need to expand in, okay, because you're subtracting the whole of this term, which means you're subtracting that x and you're subtracting that 3 as well. So we're going to expand, simplify, and then solve. So 3x minus 2x minus 3 equals to 6. 3x minus 2x is x, so x minus 3 is 6. So x equals to 9. Once we've got the x value, what we can then do is substitute into either of those equations. So it doesn't matter which one you put it into because it should work for both of them. So I'm actually going to substitute into equation 1 because y is already the subject. So I'm going to sub into 1. And then what we've got is y equals to 2 times 9 plus 3, and we can calculate that, and y is 21. So what we can then do is we can check whether we were correct or not by substituting 921 into equation 2. So we can use the second equation as a check equation. So if I substitute 9 and 21, 3 times 9 minus 21 is 27 minus 21, which is 6. So you can see that it is correct. So therefore, your answer is 921. So we can write it as a coordinate, or you could write it as the solution is x equals to 9, y equals to 21. All right. For our second equation, what we've got here is we've got 6x minus 2y is 9, and we've got y equals to x plus 2 over 2. So we do have a fraction in there, but that's okay. We can work with that. So that's equation 1, that's equation 2. In this case, y is the subject of the second equation. So we're going to substitute equation 2 into equation 1. So we're replacing whatever y is with x plus 2 over 2. So y changes into x plus 2 on 2. So we're going to sub 2 into 1. So we're starting with 6x minus 2y equals 9. And what we're doing is we're getting rid of the y and we're replacing it with x plus 2 over 2. I might actually rewrite that. Times x plus 2 over 2 equals to 9. Now, one nice thing comes out here because you've got 2 in the denominator and a multiplication of 2 in the numerator, so they'll cancel. So what we've got left is 6x minus, be careful there because there are brackets, x minus 2 equals 9. 6x minus x minus 2 is 9. 5x minus 2 is 9. So I've just collected the like terms. 5x is 11, so then x is 11 over 5. You can leave that as an improper fraction if you want to, or you could write it as a mixed numeral. So that's going to be 2 and 1/5 if you want to. I find it easier just to leave it as an improper fraction. So once I've got my x value, what I then need to do is find the y value. So again, I can put it into either of those equations, but I'm going to choose to put it into equation 2 because once I put that number straight in, all I need to do is put that into the calculator, or I'll just need to calculate that in my head if I want to. Okay, so y equals, I'm going to have 11 over 5 plus 2 all over 2. So that's the calculation we're going to do. I think that's 21 over 10. So then that would be the y value. So again, we can check this. So a check doesn't have to be part of your solution. So I need to put this sub into 2. A check doesn't necessarily have to be in your solution, but it's always a good way of making sure that you are answering these correctly. So even it might mean after you've finished a question, when you go back to check your work again, rather than redoing the question from start to end or looking at all of these calculations, this is a good way of double checking that all your answers work out. So we've got 6x minus 2y. So that's 6 times 11 on 5 minus 2 times 21 over 10. So what we've got there is 66 over 5 minus 42 over 10. Now I'm going to put this into my calculator. 5 minus 42 over 10, and we end up with 9. And that's exactly what we were meant to end up with. Okay, so sometimes you will get fractions, and you can see that the algebraic method is probably more powerful in that you can find an accurate value for your x and your y. If you were trying to read this off a diagram, you won't actually be able to read this off with the same accuracy as if you solve these using algebra. So then I can say, therefore, the solution is 11 over 5 and 21 over 10. Now, this is a bit of a review of last year, but yes, this was something that we did do right at the beginning of the remote learning. So it might take a little bit of practice to get these right. Just make sure you work through it and make sure you are setting these questions out very carefully.